Today we're going to factor trinomials. I will show you the two ways that I've seen teachers do this in the past. Basically, we are trying to undo the process of double distribution or FOIL or whatever you call it. And the easiest way to do that is to solve this puzzle of what two numbers multiply to give us 15 and add up to 8. Some teachers in the past use an X for this, and they put 15 on top and 8 on the bottom, and then you try to figure out the two numbers and you write that on either side of the X. The problem that I see with the X is that you have to remember that you're multiplying to get the top number and adding to get the bottom number. So I just use blanks because that's how my brain works. Some of us are gifted with a brain where when you look at this, it's like the two numbers just pop into your head like magic. You're like, oh, it's this number and this number. Some of us, including me, are not gifted with that. So you might have a little bit more trouble figuring out the two numbers. The best thing to do is think about 15. We can multiply 1 times 15 to get 15, or 3 times 5. Once you have the list of ways to get 15, look at those options and think, how can I get 8? If I do 3 plus 5, I can get 8, and 3 times 5 is 15. Those numbers become the factored form. Our factored form is x plus 3, x plus 8.
Wouldn't it be x plus 5?
Yeah, it'd be x plus 5, x plus 8. No, x plus 3, x plus 5. My goodness, do I just need to restart this recording again? Yeah, probably. Oh well, we'll roll with it. Okay, B. This time we are looking for two numbers that multiply to give us 12 and add up to -7. If we're adding up to a negative number, that means one of the numbers is going to have to be negative, or maybe both of the numbers are going to be negative. If we're multiplying to get positive 12, that means they either both have to be positive or both have to be negative. So, ways to get 12. We can do 1 times 12, 2 times 6, 3 times 4.
It's 3 times 4.
It's 3 times 4. 3 plus 4 is positive 7. -3 plus -4 is -7. -3 times -4 is also positive 12. So our factored form, let's see if I can get it right this time, is x minus 3, x minus 4. Okay, let's try C. We are looking for two numbers that multiply to give us -6. Those same numbers have to add up to positive 5. A lot of you, when you see 5, you think, oh, it's 2 and 3. But I don't think we can make that work here. Because to get -6, one of them has to be negative. So if we use 2 and 3, we're either going to get positive 1 or -1. That's not what we want. Using 1 and 6, if you're trying to add up to a positive number, the bigger number needs to be positive, the smaller number needs to be negative. -1 times 6 is -6, -1 plus 6 is 5. So x minus 1, x plus 6. You could also write your answer x plus 6, x minus 1. The order of the parentheses does not matter as long as one of them is x plus 6 and the other one is x minus 1. Okay, pause the video if you're watching the video. Try D on your own. So in part D, we are looking for two numbers that multiply to give us -6 and add up to -1. That would be 2 and -3. Or -3 and 2. So x plus 2, x minus 3, or x minus 3 times x plus 2. When we look at example 2, we're actually going to do example 2b. What is wrong with this factoring problem?
It's out of order.
It's out of order. So the first thing we need to do is rearrange it. -x squared would go first, plus 5x plus 14. Okay. once we have it rearranged, do you see another problem?
There's a negative in front of the x squared.
There's a negative in front of the x squared. So our first step is going to be to factor out a -1. So divide all three terms by -1. That will give us positive x squared minus 5x minus 14. This means that once we get our answer, we're going to have -1 and then the two sets of parentheses. You have to remember to drop that -1 down. Take a moment on your own and see if you can factor the inside of this parentheses. All right, this would be 2 and -7. So we have x plus 2 and x minus 7. Don't forget about the -1 in front. All right, let's look at example 3a. What do you see in this one that we haven't seen yet? xy in the middle and y squared at the end. So what if I made the y go away and this just looked like x squared plus 11x plus 10? Could you factor that one?
Yeah.
Okay, so take a moment and factor that one. Okay, so if the y did not exist, we're just kind of pretending for a moment that the y doesn't exist. We'd be multiplying to get 10 and adding to get 11. That would be 1 times 10. So the factored form would be x plus 1, x plus 10. Do you notice that I left a little bit of space between the number and my end parentheses?
Is it a y?
That's where the y goes.
Oh, no.
Okay, if I was going to multiply this out, x times x would give us that x squared. X times 10y would be 10xy. And this would give us 1xy. Those would combine to give us the 11xy.
Oh, wow.
And then these would combine to give us 10y squared. So the hack that I want to teach you is, if you see a y in the middle and a y squared at the end, stick a y after the two numbers that you find. You can basically ignore the y and then stick the y into your answer. How I really should tell you to do this is look for two numbers that multiply to give you 10y squared that also add up to 11y. And that would be 1y and 10y. But then the weird thing is, well, why are we ignoring the x? Because we know that the x is going to be the first part of the parentheses. And so basically, if you see a y in the middle and a y squared at the end, you're going to stick a y after the two numbers that you find. Basically, ignore the y, stick the y into your answer, and call it done. Okay, example 4. What is wrong with example 4?
Everything.
Everything. It is not ready to factor. It's not ready to factor the trinomial because first we need to factor out a greatest common factor. Then we can factor the trinomial. So first look at the numbers. 3, -27, and 54. We could divide all of those by 3. The first term has x to the third. The second term has x squared. The third term has x. You're looking for the smallest x, basically. So you can pull at least x out of all three of those terms. Okay, so 3x to the third divided by 3x would be left with x squared. -27x squared divided by 3x would be -9x. 54x divided by 3x is 18.
Yes.
Thank you. Now, pause the video. Factor the trinomial that's inside those parentheses. Okay, if you're struggling to find the pair, think about what can multiply to get 18. 1 times 18, 2 times 9, 3 times 6. Well, if we're trying to get -9, using the number 9 is probably not going to work. 1 and 18, that would give us 17 or -17. So we want 3 and 6. -3 and negative 6. So we have x minus 3, x minus 6. Don't forget about the 3x on the front, and that is our fully factored trinomial. I have seen this problem on an ACT test, and there is one problem in your assignment like this. Find all the integers b such that the trinomial can be factored. So this is, you've probably never seen something like this before. We're looking for two numbers that multiply to give us 16, and those numbers need to add up to b. B is the answer to this question. So we are finding all of the numbers that b could be. So first, let's think about 16. How can we multiply to get 16? 1 times 16, 2 times 8, 4 times 4. Now we need to think about what type of number 16 is. It's positive, so when we use these numbers, they either both have to be positive or they both have to be negative. So positive 1 times positive 16 would be positive 16. Negative 1 times negative 16 would also be positive 16. So if I used 1 and 16, what would b be?
17.
17. 17 is one of the numbers that b could be in order for this to be factorable. If I gave you x squared plus 17x plus 16, you could factor that trinomial. But it's not the only answer. What if we were using negative 1 and negative 16? What would b then be? Negative 17. So if we had x squared minus 17x plus 16, you could also factor this trinomial. So for each of these pairs of numbers, you have to use both positive and then both negative to get all of the possible things that the letter b, that could be the letter b. That's too many b's in there. It's really screwing with my brain. So if we used 2 and 8, what is 2 plus 8?
10.
10. If we use negative 2 and negative 8, negative 10. Now take a moment and think about the 4s. What are the other two things that b could be? 8 and negative 8. So you're looking at, because this is positive 16, these numbers either both have to be positive or both have to be negative. So first find all of the ways, like if both of them are positive, 17, 10, and 8. Then if both of them are negative, negative 17, negative 10, and negative 8. All right, on your assignment sheet, there is a mistake. On your assignment sheet in your notes, it says that the last problem is number 583. It's definitely just number 58. I stuck a 3 on there accidentally. So if you're looking at your assignment sheet, cross off that 3 at the end. Your assignment starts on page 279. There are 10 problems.